Check. Is the voice still there? I think so. Yes, everything seems to be in place. I need to check because one time it gave me trauma and it didn't record. So come back after what happened and the ton of information we got yesterday. We are changing our route of what we are actually studying. And I forgot to change that one. Anyway, so actually there is two versions of the map that we have seen yesterday. We check more about what exactly DevOps are and what they do. Uh, so they basically do automation with the backend. So you have people working in the server and then people working in the backend, and then you have DevOps in between. So they need Python for automation, which is the book that we already said we will be studying. But since I already have a background with Python compared to the other stuff here, I thought it might be as well the best chance to actually try Linux first. Since I'm already going to work on a project, I think in May till December, using Python. So I will be studying Python with a group afterwards, so it wouldn't be an issue. Networking protocols, I took an introduction course to that, so I at least know what these stands for. Docker, I know what it is, but that's about it. Get and GitHub, worked with them for a bit. AWS is the big guy in actually all of this that we will probably stay on it for a while. And everything under that part is completely new, so at least I know what Linux is. So I was trying to install Linux, but I forgot what is the boot key for my computer, so I have to check my specs for that later. But anyway, since we are doing the Linux first, of course, there is another map to get to Linux. But from what you can see in here, file system, package managers, managing services, we'll be studying all of that, but so there is the documentation about it, or a better version is the Try Hack Me website that has a built-in Linux system that we can use. And they even have a tutorial for it, which I do plan on using, but instead of watching the tutorial, I thought about just reading the documentation for once. So we all know what Linux is, or at least I hope we do. So I'll open the machine here. The machine has a timer, that's the thing, around 1 hour every day. So I'm not sure if that will work or not, but we will see. If we exceeded the limit, we'll probably have to install our own, which I'm working on. I didn't want to do it in a virtual machine because it's a bit slow. I tried using virtual machine in our computer lab before. It's very slow. It works, but very slow and not enjoyable. If it's slow, I'll probably get frustrated with it easily, like I did before. So we have the basic commands, and I think it opened this website. Introduction to Linux file directory. If you are new to Linux, don't worry, we'll guide you through each step, explaining what to do, why are you doing this, lab design, Let's cover some basic Linux file system. Think of it as a tree structure. That's one thing I remember hearing about, that everything in Linux is a file. So think of this as a tree-like structure for organizing all the files on your computer. Unlike Windows with its drive, letters C, D, and etc., Linux has a single root directory. I think this mark for it, or the tilt mark, from which everything else branches out. Directory. This is the Linux term for folder, yes. A file is everything, almost everything is a file. Regular documents, directories, every hardware devices are related as a file, are treat, are treated, okay. The writing is a bit weird. This yeah, unify approach simplifies many operation. Then we have the path. This is like the address for a file or directory. We will learn about absolute path, which starts from the root directory, and relative path. I heard these terminologies while working in IntelliJ. When you're trying to get a path to a folder, terminal, that is your command center for interacting with Linux. It might look intimidating at first, but you will soon find it's a powerful tool for managing your system. I played with the terminal a bit here and there through my years. Funny enough, I also installed Kali Linux when I was like, what, 12? And then I uninstalled it again because how do I use the terminal was one of the questions I had. Linux, okay, file research, one provide powerful tools for finding files across the system. We'll explore the like find and wish to help you. Okay, since there will probably be a lot of command lines to remember, docs. We'll probably need to make a separate folder for that. The Linux folder. Okay, I have my caps lock on, never mind. So here we'll be typing all the commands. Where's the numbers? Yes. We'll be typing all the commands that we see here because I know for sure I will be forgetting them tomorrow. So explore the Linux directory structure. In this step we'll take a tour of the Linux file system. This will help you understand where different types of files are stored and how the system is organized. Okay. Open your terminal. You should see the thing with the dollar sign. Was it the dollar sign? Okay, let's see. Yes, it was. So I have the dollar sign here. Actually, let me bring this one a step closer. Or actually, a separate one so it's easier to switch to. Yes. You should see prompt ending with the dollar sign. This is where you will type your commands. You're currently the project directory, which is home lab x project. Let's confirm this. PWT stands for print working directory. It tells you where you stand with the system. Okay. PWT home try hack me home, then that, and then the project. More or less the same. So we have our first one, PWT print working directory. Now let's view the entire directory structure. 3/. Okay. How about 3 space then dash? Okay. Not found can be installed with snap install. Okay, AP. Let me check here. This shows the directory structure in a tree-like format. I don't get that one because it's not happening. The argument tells it to start the root directory. Don't worry about understanding everything you'll see. You will focus on the most important parts. Let's explore some main directories. The /home, etc, and pin. Home is where user directory are stored. Each user typically has their own directory here. Each user has their own directory, so we can have multiple users. Okay. Contains system configuration files, the etc. Okay. Pin holds the essential command binaries program that need to be available for all users. Okay, so this one for command, this one for configuration files, and this one for user stuff. Okay, let's navigate the root directory and list its content. I do remember cd because cd and then this, which directory we are in. Yeah, we are now at the root. Now let's list the stuff in the directory. Okay, here is the bin that we talked about. Was bin for again? The home directory is for the user. We have bin etc is for the commands, if I remember correctly, and this for configurations. Yes, no, the opposite. etc for configuration, and then we have bin for the commands. Let's bring this here. Have cd tilt to access, or to just go back actually. To just go back and ls to list files, and this might be a bit out of the command line thing we are writing, but I should write what home etc it's, or etc, I'm not sure how to call it, and then bin home user information etc file configuration, and then you have bin command lines. Actually, I do remember seeing a video about Linux file system. We will get to that after we finish at least a bit of reading here. cd means change directory, and this takes you to the root directory. Does it take me to the root directory, or actually any, or just back one step? First of all, I should write that this one means where's cd. Hello Firestorm. New here, or have been there for a while? Wait. Forgot what. You welcome. As you can see, we are doing some Linux. Just practicing though. Zero background on Linux. The only background I have is doing some lab classes at school. That's it. What about you? cd stands for change directories. Change directories. What else do we have here? We wanted to check if this one actually takes us back. So let's just go into the bin. Let's everything here. And I think the green one should actually be a file, while the other, the gray one should be a folder. So do you hate Linux, or you actually like Linux? It seems like Linux user seems to like Linux, while people who don't use Linux seems to hate it. So it's either you hate it or you love it. I never seen someone in between. So pwd. So we can see here that we have /bin. Actually, let's get back. cd ls. How about we go to the home directory? Probably we have more folders there. For how long have you used Linux, or you're just starting with it like I'm doing right now? So let's go inside the home. You want to list the stuff there. We have Ubuntu, and then we have track me. Let's go to try. try hack pwd. Okay, so we are 2 paths in. Now if I try to type this and then pwd, okay, so this one actually doesn't go back, but it goes to the root directory. So yes, I did write that wrong. Goes to the root directory. I was actually trying to study a bit of C++ a couple of days ago. I forgot the website name. It was dev something. It seems like an interactive way to study C++, so I was trying to actually do it. And since my background is Java, I thought maybe dealing with memory management and stuff like that would be really interesting, but I didn't have enough time. Now I have to study Python. A lot to study actually, but little time to do that. I mean, if you have enough 2 hours every day, I think you can manage to do it in relatively 2 to 3 months. If you have already a good background, it will be even faster. But we will see. It took me, I think, 2 weeks to finish JavaScript, but JavaScript isn't a programming language, am I right? So that's the website. No, need the file. So this one, change directory, and it takes you to the root directory. ls lists the contents of the file directory in detailed format. Called option for flag, which modify the behavior of the command. I'm not sure what -l means. How about ls? That's ls, and then we have ls-l. Nope. I have to ask. And Linux. I did try Unity, but there's too much physics for my taste in Unity. For my taste, at least. I didn't really want to get into game development that much. But I did try Unity, but that was like in, what, 2018 or something like that. Tried it for a bit, not that much. In Linux, what does ls-l? It is used to list files in the directory in a long format, which it provides details, information about the type, file type, and permission. I remember seeing this annotation in the operating system class that I took, but I never understood what it means. So, ouch. Number of hard links, owner of the file, group, file size, last modified date and time, file directory, and name. Yes, it does show a lot of stuff here. Okay, so it's just a list with more details. How do I even write that? ls-l, like ls, but with extra steps. So if this one takes me to the root directory, I remember this one was the one being used. You mean as a programming language? I only studied Java so far and web development. Doing backend, really, not even the front end part. I finished studying HTML, CSS, and JavaScript. I say studied, but I didn't do any project. And then while I was trying to study the framework, someone advised me not to get into web dev because apparently it's full of people. Okay, no, I live in Germany right now. So they still teach in school. Some schools teach Python, but ours teach Java. But after doing Java, I did have a hate relationship with it before. It's actually better because it teaches you strong typing. And that's how I come to hate JavaScript. It is short. Okay, yeah, I remember this one, but I never remembered what it does. This is a short that always represents your home directory. Okay, what's the difference between home directory and root directory? I think that's two different. What's the difference between home directory and root directory? I think the root directory is this one, and it's the top level location, and the home directory is typically located under home. Okay, so it's not the home itself, but the one located under it. But it is a user specific. Okay, I see. So we have cd and then that mark. Actually, let's check where are we right now first. We are at the root directory and we want to go to the home directory. Actually, let me figure out how to write this mark. Yes. Okay, so it's not the home folder itself, but rather the user that's inside the home folder. Okay, I see. You have cd and then you have this mark, the user folder inside the home directory. And then I probably have to write this question somewhere. Home directory versus root directory. Root directory is the top level one, top level directory, while the home one is where the user information is from. Okay, how many command lines did we learn till now? We have the pwd print working directory. We have the ls lists. I think it was list something, but I'm not sure. Then we have cd and then root and then lsl. Okay, so far so good. After this step, you should have a basic understanding of Linux directory structure and how to navigate it. Remember, it's okay if you don't memorize everything, but you can always use these command menu yourself. Understanding path and navigation. Actually, before we get into the path and navigation, there is a lot of things in the root directory. The thing about the root directory is there is a lot of files here, and I don't want to go to each file of them, so I would rather watch a video about it first. Actually, some of the name structures here is also in Windows, so.
But not everybody understands what the directories are used for. To a Windows user, opening the file manager looks very much like opening.
Okay, do I have my Windows structure here? Because I remember opening the C and seeing the bin folder even here. Okay, I'm lagging a bit. This, then we have the C, program files. Nope, I want the user one. Yep, not the public one. I swear I have seen. Okay, we have the SSR here also. Postman. Okay, these are program files that I used to have. Okay, maybe I was imagining stuff. So I mean, you can still study, but I think it's already past 6 p.m. for you guys. So I thought I have seen it somewhere, the same file structure of pin, home, and the other in C file in Windows, but maybe I'm mistaken. Okay, I am hallucinating. Hey, we are studying here, so everyone can study with me. Maybe I should change the title of the video to study with me rather than actually just coding.
The home folder in Windows, and all very familiar. You've got
Uh,
your
okay.
documents, your downloads, your pictures, your videos. Same thing. That is until they explore up the tree looking for the C drive.
The thing is about the website, I don't even have that manager. I only have the terminal to work with. So I'll prefer it to be that way for now.
Where's program files? Where's the directory that Linux is installed into? How do you find anything? Let me explain.
Yes, please.
I'll take a quick minute here for new Linux users coming from Windows. Windows and Linux
That's me.
evolved in very different ways. Once upon a time, there was a thing called MS-DOS, the disk operating system. It was command line only.
I never heard of that term before. What is disk operating systems? Sure. Consider it a studying ASMR. Disk operating system refers to an operation system designed to manage and control hardware and software resources of a computer, okay? So it's an operating system. Okay. With focus on handling data storage and retrieval of on-disk drives. Okay. It acts as intermediary between the user and the hardware. So it's literally an operating system. Okay, let's continue.
Only, but you could still run programs, games, and WordPerfect, but you didn't need Windows. Windows was added to PCs, and you could install it on top of DOS. You would start up your computer and type in Win to start Windows. It used letters to assign drives, with A and B being removable disks, since
Okay.
PCs only had floppy drives. With the addition of hard drives, the letter C became the letter for your internal disk. Additional disks were given the next available letter. You could install things in DOS wherever you wanted to. Windows installed itself in its own directory called, funny enough, Windows. Later, Microsoft
Okay.
changed how it booted by evolving their kernel to be less and less dependent on DOS and eventually allowed Windows to boot directly without DOS at all. Microsoft's file directory structure kind of stayed the same. Now Linux is different, and so is its file structure.
Okay.
It also doesn't install applications like Windows does.
No, from what I understood, you only use the terminal to install it directly, not even from like the internet.
Windows 95, Microsoft created the Program Files directory, which was
Okay.
default installation directory for most applications. For the most part, Linux follows Unix traditions, which is why it uses the forward slash instead of the backslash like Windows. Linux also cares about capitalization, so you can have things like this: file, 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 file.
Okay, that's ridiculous.
They're all named file. They all use different capitalization, so Linux will allow this because they're technically not named exactly.
So basically, I need to avoid naming any of my files in capital letters. Okay.
The same. Mac users who have explored their hard drives might find Linux a little more familiar. This is because Macs also evolved from a Unix ancestor, more specifically BSD. So let's have a look at the root
Okay.
and go over how all this works. This layout, for the most part, is outlined in the File System Hierarchy Standard, or FHS, which defines...
Okay. Need to check on that one also. What is FHS? It's a standard that defines a directory structure and context in Unix-like operating system like Linux. Its primary goal is to ensure consistent and predictable structure across files. So it's the way that the structures are, the folder are structured. So you had the root directory, which is the top level. BIM contains essential binaries to execute, troubleshoot, recover, and repair. But I only remember it for having the command line. So did I even type that? I think, yeah. Command lines, yes. Then we have the other ones that we will be talking about, I think, in the video.
The structure and layout, and is maintained by the Linux Foundation. I want to note here that not all distributions follow this. Some do their own special thing. Also, several ways of structuring the folders has changed over the years, but most of what follows still applies in most cases. So let's go end to end, starting with bin. Bin being short for binaries. These are the
Binaries.
binaries.
Okay, so that's what it's called. binaries.
which is another word for programs or applications. Things like these are the most basic binaries, which is another word for programs or applications. Things like ls to list your directory,
Mhm.
count to display the output of a file, and other basic functions are stored here. Skipping ahead a little bit, I also want to point out sbin. These are system binaries that a system administrator would use and that a standard user wouldn't have access to without permission.
Okay, I see. So we also have the sbin, which is system binaries. Command lines only for administrator.
Both of these folders contain the files that need to be accessible when running in single user mode, as opposed to the usual multi-user mode. Single user mode is a special
Okay.
mode that boots you in as a root user to allow you to do system repairs and upgrades or testing. Networking is usually disabled in this mode because of security issues.
Okay, so if I install Linux in my device, it will probably be a single use. I need to.
Mode that boots you in as a root user to allow you to do user wouldn't have access to without permission. Both of these folders contain the files that need to be accessible when running in single user mode.
Okay, so we have single user mode versus multi-user mode. Single user mode versus multi-user mode. Single user mode, user is designed with the direct root. Again.
These are system binaries that a system administrator would use and that a standard user wouldn't have access to without permission.
Okay.
Both of these folders contain the files that need to be accessible when running in single user mode.
And so in single user mode, we have access to all. We have access to both bin and sbin.
As opposed to the usual multi-user mode. Single user mode is a special mode that boots you in as a root user to.
Okay, and it boots the user as the root user. Okay, single use. Yes.
Do system repairs and upgrades or testing. Networking is usually disabled in this mode because of security issues. When you install a program in Linux, it's typically not placed in these folders. Next is boot. This is a folder you don't want to play around.
Then what about multi-user mode? Okay, we need to ask this more. So what's the difference between single user mode and multi user mode? Is primarily used for system maintenance, troubleshooting, or repair. In the mode, the system is booted up with a minimal service, and only one user has access to it. Can access the system or not started. Use case it's used for tasks like repairing file system, changing systems, settings, recovering, forget password, or fixing boot issues. Multi-user mode is the normal operating mode of a system where multiple users can log in and interact with the system simultaneously. Okay, that's what I thought. Multiple users can be logged in, so that's where the SSH comes into play. Okay. So multi-user can have multiple users access it remotely, and that's through SSH. All system and service background processes are running. That includes network services, graphical interfaces, printing services. So, aka network. Any type of network is using through the multi-user one. So yes, we have system services, background, network services. Like network services.
It contains everything your OS needs to boot. In other words, your bootloaders live.
Boot is just for anything my system needs to boot. Very self-explanatory. Maybe I should highlight these in some other color, but probably do that later. Then we have boot. All the files needed for my system to boot.
Live here. Next, we have CD-ROM, which I'm going to skip because it's not in all distros and it's more of a legacy.
CD-ROM, I'm not sure if that's here. Let's go back to the root directory. ls. Yes, CD-ROM is not here, so skip.
Mounting point for your CD-ROM. So let's move on to dev.
Do we have dev? Yeah, we do.
This is where your devices live.
Dev for devices, of course. Dev, aka devices.
Linux, again following Unix, has a standard where it was decided everything is a file. Here you'll find your hardware. A disk, for example, would be dev/SDA. Here, and the partition on that disk would be, for example, dev SDA1, SDA2, and so on. You can also find everything else.
No, actually, you need to explain that again. What?
A disk, for example, would be dev/SDA.
Dev/SDA. Why SDA specifically? I'm not sure, but let's actually try to access the dev part here. CD dev. Dev for this. My bad. Dev. ls. So what do we have here? We have loop, char console, CPU. Okay, let me write this before I even forget it. Everything in Linux is a file, including my hardware, and they exist in this directory. I think that's a good explanation for me to remember. We have the CPU here. I'm not sure about the other stuff that we have here, but we don't have the SDA that he's talking about. So, but you do have disk. Actually, let's try to actually get into disk. Yes. How do you get back one step in Linux? How do you get back one step in the directory in Linux? Okay, c dot dot. Let's write cd dot dot s. Sorry, ls. Okay. Also, that's a good place to put it. I'll put it also here. cd dot dot. To go back to the previous directory.
Here, and the partition on that disk would be, for example, dev SDA1, SDA2, and so on. You can also find everything else here from your webcam to your keyboard. This is typically an area that applications and drivers will access and is rarely something a user should be dabbling in. So going back to root,
Okay.
the next folder is etc. The name
etc. I think for configuration, etc. is file configuration.
The name of this folder has been argued as standing for etc., edit to configure, as well as others. But it has been
Okay.
confirmed by Dennis Ritchie that it did indeed mean etc.
Why?
This folder is where all your configurations are stored. However, when I'm talking about configurations, I'm talking about for things that are system-wide, such as apt. In this folder, for example, you would find the list of all your sources, what repos your system connects to, as well as its various settings. So if you're looking for something that is a system-wide application,
Okay, I see what you mean. The configuration is specifically file configuration for the system. It's different than the boot because the boot is the one that we use to open the system, while the config is to configure the system. Yes. Okay.
and not a per user setting. For example, LibreOffice would have settings in each user's folder, and it wouldn't be system-wide because each user can have different settings. And this brings me to the next folder, which is home. However, I'm going to save this for the end because there's some things I want to discuss about it, so we'll come back to it later.
You'll see.
Next
Yeah.
are the lib folders. This includes lib, lib32, and lib64.
Oh, do we have left? I don't think so. CD ls. We have yes, lib normal, then 32, 64, and x32. That's a lot of libs.
These are where the libraries are stored. Libraries are files that applications can use.
So we have here lib APA libraries. Yeah, actually I should change the colors here to maybe something like blue, since it's also blue in the file system itself. Yeah, I had different shades of blue here, so the first one was actually better, so we will go with just blue. And now sbin, then we have the boot, then we have the devs, and then we have the lib. Okay, now let's go back.
Perform various functions. They're required by the binaries 30-bit, so we'll come back to it later. Next are the lib folders. This includes lib, lib32, and lib64.
I have one
These
extra
are where
one.
the libraries are stored. Libraries are files that applications can use to perform various functions. They're required by the binaries in bin and sbin, for example.
Oh, okay. They are required, but before that he mentioned something else. I need to repeat that.
This includes lib, lib32, and lib64. These are where the libraries are stored. Libraries are files that applications can use to perform various functions.
It's the same concept with libraries and programming. When you insert a certain library to be able to use certain stuff. For example, React is a library. Okay, I see. Used by other programs like in commands to perform certain tasks. Perform tasks.
They're required by the binaries in bin and sbin, for example.
Yes, how you said
We
that.
have media and MNT.
Let's check. We have media, yes, and MNT.
Or mount. These directories are where you would find your other mounted drives. It can be a floppy disk, USB stick, external hard drive, network drive, or even a second hard drive. So if you're looking for that A, B, or D drive, this is where you want to be looking. Now, this media folder wasn't always around. It was typically just MNT, and that's where you mounted your storage devices.
Okay.
Nowadays, most distros automatically mount devices for you in the media directory. So your USB stick that you inserted would be in media, username, device name. So why are there two directories? Well, if you're mounting things manually, use the MNT directory and leave the media directory to the OS to manage. Most distros and file managers, such as Nautilus, for example, what I'm using here, and Dolphin and PCMan FM, will have something on the side here. For example, in Nautilus, I can click other locations, and here I can access my other devices. If I had a USB stick plugged in right now, it would show up here, and I could simply click on it and access it. Next down the line is open file managers such as Nautilus.
Mint and media. I still don't get the difference between the two. So last question about this. What's the difference between slash MNT and wait, the slash, I think it's a different slash. Let's get back here. Okay, it's not writing and it's disconnected again. PWD. No, it's the same slash. Okay. We have what? Slash. Okay, no, we are actually in ChatGPT. What's the difference between slash mint and slash media in Linux? Yep, both of them are for managing drivers. But they serve slightly different purposes and have different conventional uses. The mount point is used as a temporary mount point for file systems that are manually mounted by a system administrator. If an administrator wants to mount a device, partition, or network share temporarily, they would typically mount it under the main directory. Okay, media for automatically mounting. What do you mean by mounting exactly? By mounting. In context of Linux, mounting refers to the process of making a file system accessible to the file system. Okay, I see. So they don't read automatically if I insert something into them. And that's why we have the media and the other one. Okay, I see. We should probably underline this one for readability. And we have here this one, just for terminologies. Okay, now we understood mount. Let's go back to our previous question. Mint is temporary, while media is permanent. Is technically used for automatically mounting removable media devices. So okay, so the media one is for removable devices, while the other one is for my actually internal hard disk. Okay. We have slash MNT versus slash media. Media is for automatic mounting. I said, was it automatic mounting? I'm not sure if it's that technically. Okay, temporary mounting, that's also automatic. Where? Yes. Okay, so it's correct. Media is for automatic mounting and for temporary not disk storage. but it was for something else also. It's not for temporary, but rather removable media devices. Or removable media devices. Like USB. Okay, now the media, we understand what it's for. Now let's back to the MNT. Point for file systems that are manually mounted by system administrator. I need more explanation about that. Explain to me /MNT more. Use for mounting files, which means connecting external devices or file systems to the system main directory structure. It is traditional intent to temporary mounting. So both of them are temporary mounting, but mount point for external devices like hard drives, USB drives, network, and it doesn't make a difference from the media one. And how do you mean by, okay, the only difference is one is automatic and one is manual. MNT on the other hand is manual. So that's a thing I need to understand. What do you mean by exactly manual? Manual mounting was commonly used for an administrator to mount a device for a specific task, such as accessing external storage or preferring for backups. Explain to me the difference between manual and automatic. Refer to the way devices like or network shares are mounted. Let's break the difference. Manual mounting requires the user or system administrator to explicitly mount a device or a system using commands. Okay. Command line basic mount command is used to perform manual mounting. Example, let's say you have an external USB drive that you want to mount. First, you identify the device. Okay, dev sp, of course it will be in devices. Then create a mount point, sudo mecter mnt usb, then mount it. Okay. So the first step would be that the device will be identified, but in the device folder, because it's technically a device, like the CPU and the graphic card and that stuff. And then you mount it to the media manually. Automatic mounting will happen automatically. Okay, I need to explain that. For example, the flash drive will be identified in the dev section. Then we mount it to /MNT. So that's the difference. One is manual and one is automatic. But that's not the only difference we have. We have two differences. Automatic and then the removable and not removable. So what's the difference in usage between /media and /MNT? How and when they are used for mounting system. Manual mounting, we do it by MNT, sure. Media is automatic, designed to be used removable device. Automatically mount the device. The system mounts when they inserted and are connected via USB drive. using media. So if the storage device I am inserting is removable, we use media, but if not, empty. Okay, I guess so, but does that mean we have to manually mount our any extra storage that we need in order to actually use it? Wow, I never expected that. Interesting. So I have to mount. Okay, let's ask this also. So any time I add new storage to my computer, like a new SSD, I should manually mount it to MNT. I see the difference, but the one question I have is why do we need to specifically separate manual and automatic mounting? It seems very useless to me. The distinction between manual and Linux is more for key reason, or related to how the system interacts with the storage and level of control and automation and user or system administration. Manual mounting gives system administrator or advanced user more control over when and where a device is mounted. Generally speaking, we will mount it in the MNT, right? So you technically, do you have a freedom if you only have one option? I mean, you can still put it on the other, in any other directory, but the recommended one is the MNT. So if you want to temporarily mount a storage device for a specific purpose like backup and data recovery or system maintenance, you might prefer to mount it manually. You decide where it should be mounted and how it should be accessed. Custom mount location, you may have a particular directory structure for your system and want a device to be mounted to a specific location. Okay, that makes sense. Manual mounting for non-removable devices. For non-removable storage devices, you may prefer to mount them in a specific place for consistent or performance reasons. Okay. Automation for removable device. Automatic mounting is essential for removable media, which are often connected and disconnected by the user. Without automatic mounting, the user would need to manually mount and unmount each device. System organization and maintenance, security and safety, resource management. So if I don't want to have control over which directory my disk is being mounted to, then I should go with mount. With media, sorry. Automatic mount, yes, okay. Let's say I have a scenario where I need to back up my data from a Linux server. Would I register that as automatic mount or manual? For backing up data from Linux server, the choice between largely depends on the nature of the backup task and how you want to manage the backup. Here's a couple of scenarios. Temporary backup, manual mounting. Okay. Automatic backup to remote or network storage. Okay, yeah, I forgot about that. The device shouldn't be actually a physical one, but it can also be over a network. For the automatic one, you would probably need automatic mounting. Okay. What are devices that can be considered as mountable, if that's the word? The only ones I know are USB, SSDs, and hard disk. I can't think of anything else actually, but it should be also a network. Any storage devices or that can be reached to a file system hierarchy. While USB and SSD are the most common example, there are actually many types and resources that can be mounted here. USB, external, all the stuff we know about them. SSDs, network, allow sharing of directories across a network, used for mounting remote file system. Yeah, okay, I see. Memory cards is also one of them. Virtual file systems, cloud storage, RAID. So anything that's stored is considered a storage device. Okay, that's interesting. I never thought of it that way. What is considered a storage target for MNT and media? Anything that has a file hierarchy structure. Internet or over the cloud is included. Okay, that's another new thing. Okay, we are getting a lot, but that's it for. I think I have delved deep enough into the media and MNT. But in case of wanting to back up and it's automatically, it says here automatic. I'm not sure why we prefer that one, but I'll keep it as simple as that right here. We don't need more. So we have here slash MNT and media. For mounting storage devices. Oof, that's a lot. Now let's check back.
For example, what I'm using here, and Dolphin and PCman FM will have something on the side here. For example, in Nautilus, I can click other locations, and here I can access my other devices. If I have a USB stick plugged in right now, it would show up here, and I could simply click on it and access it. Next down the line is OPT. This is the optional folder, which is usually where manually installed software from vendors resides. Although
OPT, interesting. I should probably open another place so that I also know what was that website called again? There was a website that can give you a terminal. Learn Linux. I think it was that one. Hacking Lab. Sign in. I remember having an account here. So now I have two places to open it, like online. But so what are the models that I have here? In progress modules, yes, Linux fundamentals. And then we have, I think, a terminal right here to start, yes. So I'll still keep this website just to check on stuff. Terminate the machine because it's already not working. While it takes some time to actually open that one, there is a lot of reading here that I'll probably do later. They also have one for the navigation that we are currently doing, so that's bash, I think, yes, and that's the terminal here. So ls pwd is better actually. Actually, I think we should be opening the green one, not this one. That's the PowerShell, and that's the $sign that we need. So yes, okay. Let's call it parrot terminal. I need to also search a bit about the different types of terminals. pwd. We are inside the home and inside the user. cd. Then we go to the root directory. ls. Yes, I want to keep that here. Actually, let's go inside the option then. What do we have here? HTTP, README, Microsoft, WebSockety, WebSockify. I'm not sure how to say that.
Though some software packages found in the repo can also find their way here. VirtualBox Guest Editions is one example. So here, for example, is a VPN software that I installed and the drivers for my brother printer slash scanner.
Okay, now we have a new one called /opt, which just stands for optional. Yeah, third parties programs are located.
Scanner. This is also where you can install software you've created yourself. This folder is where I place all the applications I've written for Scion Linux. Next we have proc. Proc is where
Actually, I need to add that. Plus the programs you created yourself.
you'll find pseudo files that contain information about system processes and resources. For example, every process will have a directory here which contains all kinds of information on that process. An example I can show you here, if I open the system monitor, I can see Deja Dupe Monitor's process ID, or PID, is 2344. So if I navigate to proc2344, which is the PID for the Deja Dupe monitor, I can see all kinds of pseudo files here. This is much like dev, where they're not actually files on the system. This is the kernel translating other information to appear as files. So for example, here I can open the status file and it'll show me all kinds of information on that process. There's tons more in here, but this isn't something you want to play in. If you are a developer, if you're writing applications, this is very handy. Here, play information, for example, here, kernel, much for the Deja 2.3 Nation on that. For example, find place all the applications I've written for Scion Linux. Next,
that one is pretty important.
Find pseudo files that contain information about system processes and resources.
System processes. What does the system processes in the /proc mean? Is a virtual file system that provides information about the kernel, running process, and other system details. It's dynamic in-memory file system that does not contain actual files on disk, but instead expose real-time data about the system. Files and inside the proc, recent process, system resources, and kernel parameters. Give me a top-down view to what actually is in that file and when it can be helpful. It's a virtual file system that provides wealth of information about the kernel running processes. So information about stuff that's actually running at the same time. It's dynamic. We want to add that part. Process specific information. CPU information. Memory information. So that's where you would actually handle the hardware directly. Summary of practical use. Debugging, turning systems, hardware diagnosis. Okay, give me a real life scenario where knowing about this would be helpful. You are an IT administrator managing a Linux-based web server. Recently, you have a report that the web application is responding slowly, especially during peak traffic times. You need to figure out what's causing the slowness and optimize the server performance. Okay, I see. So now we have /proc. Actually, we should actually specify that it is for processes. It shows information about the current working processes on the computer, and as well as information about the resources, since it interacts directly with the kernel. Okay, how much do we have left? It seems to be a lot.
For example, every process will have a directory here which contains all kinds of information on that process. An example I can show you here, if I open the system monitor, I can see
GNOME Shell, GNOME Software,
or PID
daemon.
is 2344. So if I navigate to proc 2344, which is the PID for the Deja boot monitor, I can see all kinds of pseudo files here. This is much like dev, where they're not actually files on the system. This is the kernel translating other information to appear as files. So for example, here I can open the status file and it'll show me all kinds of information on that process. There's tons more in here, but this isn't something you want to play in. If you are a developer, if you're writing applications, this is very handy.
Yes, I can see.
Information like for the CPU, for example. This will give you all kinds of information on the CPU, and you can also do uptime, which will print out your uptime for your system. Next is root. Root is the root user's home folder. Unlike a user's home folder, it does not contain the typical directories inside, and it does not reside in the home directory. You can store files here if you wish, but you need root permissions to access it. The location of this directory also ensures that root always has access to its home folder in case you have the regular user's home directory stored on another drive, which you cannot access. Next is run. This one's fairly new.
I'm not sure about the root part. Yes, no problem. cd ls, and what is the root? It's similar to the home, but not actually home. So okay, I don't see it. Yeah, okay, no, never mind. It's here. So what is the root directory for? Root directory is the topmost. It's not the root. Not that root. What is the /root directory the home directory of the root user. I'm still not sure what that means. In Linux system, it is separate from the root directory, which is the topmost directory of the file system. How is that different from the home directory? The home directory of the root user. Root directory is specifically where the root user personal information or personal file configuration and settings are stored. Just as a regular user have home directory, typically home username, the root user has a home directory as root. Okay, now what's the difference between /home and /root? Both serve as home directories in Linux, but they serve different purposes. Home is the default home directory for regular user on the system. Each user on the system has their own subdirectory within home, named after the username. Yes, so we have multiple users. In this case, if I remember correctly, if we went cd home s, we have Debian HTTP, and then that's our user. Yes, so I know that part. Down direct for root user. This is where a root user stores their personal file, script, figure, and administration. Only the root user or user with administration can access the root. Okay. But in a single user, both root and home are technically the same. You're right, in a single user category be the same in terms of purpose, but it breaks down more clearly. A specific operation. Okay, the way I view it is like this. You have the home directory for every user, but the root directory is for a specific user that have administrative roles. Actually, I want to check if that sentence is correct. So, home is for every user, while the root is for administrator type users. No, that's it. Yeah, exactly. You're right. You got it. Yeah. Okay. So now we have a slash root the same as root, where it stores user data, but it's specific for admin roles only and administrator. But now that I think about it, let's access the root, I guess. Okay, we still have this, and we still have that also in the home. So both of them, they have the same thing. So both of them will have also subfiles for the user. I mean, yeah, I guess it makes sense if you want to have user information, yes. But the only difference is the hierarchy of the user. Normal user will go through home, while root user will go through root.
New, and different distros use it in slightly different ways. The location of this directory also ensures that root always has access to its home folder in case you have the regular user's home directory stored on another drive, which you cannot access. Next is run. This one's fairly new, and different distros use it in slightly different ways.
cd ls. Do we have run here? Yes, we do have run.
It's a tempfs file system, which means it
Tempfs.
This also means that everything in it is gone when the system's rebooted or shut down. It's using
Okay.
processes that start early in the boot procedure to store runtime information that they use to function. We've already covered sbin, so next down the line is snap. This is a
Okay, that was fast. So that, what is it?
folder.
The run is exactly a RAM folder. Slash run. All the files that are there will be running on the RAM and will be deleted at some point. Okay, that was very easy one.
Where snap packages are stored and are mainly used.
We have snap packages. Where do we have snap here? SRV. Snap. I see no snap. Snap. Nope, I don't see any snap here. Anyway.
By Ubuntu. Snap packages are completely self-contained applications that run differently than regular packages and applications. This will be covered in a future video on its own.
So I will leave it here.
To explain. SRV. This is the service directory where service data is stored. It'll probably be empty for you, but if you run a server such as a web server or FTP server, you would store the files that will be accessed by external users here.
Literally a server file. Okay.
This allows for better security since it's at the root of the drive, and it also allows you to easily mount this folder from another hard drive. Next down the line is sys.
Oh, my brain is overloading information right now. That's all for the directory. Now we have serve, aka server. That's the information that you want to share as a server is stored. If you are not running a server, that folder will be empty. But good to know that we actually have our place just for our server information that we want to share with other computers. So
the system folder has been around a long time. It's a way to interact with the kernel. One older example is writing to a file using VGA's.
Let's check here. Where is the SYS?
Switcheroo and change settings on graphic cards in a hybrid system. This directory is similar to the run directory and is not physically written to the disk. It's created every time the system boots up.
Okay, so we have the SYS, which is system, like the run, it is also stored in the RAM. But the only difference is this is where system information. What's the difference between root? Not root. There was another file that used to store information about the system, but I forget which one. Probably root. Root is where it stores data. No, not root. Process. Yes, this one is for processes.
Interact with the kernel. One older example.
Yes, this one interact with the kernel. We had another folder that interacted with the kernel. Optional were third parties, processes, current information. Yeah, it's processes. So what's the difference between sys and process?
Mount this folder from another hard drive. Next down the line is sys. The system folder has been around a long time. It's a way to interact with the kernel. One older example is writing to a file using VGA switcheroo and change settings on graphic cards.
Another difference that I need to check. Both of /proc and slash sys interacts with the kernel. What's the difference? Right, about the kernel and system data, but serve different purpose. Proc read-only interface for kernel process. It allows users to access details about running processes, and it's only read-only. Interesting. Okay. Key points, information such as that. Let's go back to the system. Provides a read-write interface to interact with the kernel and device configuration. Oh, okay. So I can only read information in proc, but I can also write them in sys, and sys is in RAM while proc is on hard disk. Is that correct? Reading system information such as process detail, kernel parameters, read-only, storage location are virtual. This means both of them exist in the RAM. Okay, both of them are on the RAM. Did I write that part? I don't think so. Just the information about the kernel system. Okay, let's just type here RAM. But unlike proc, it also writes not only read only. Like about the kernel and device settings. Well, this one is process settings. Okay, that's also another difference. Device settings. Well, this one is process settings. I see the difference.
In a hybrid system, this directory is similar to the run directory and is not physically written to the disk.
So we have 3 directories that run on the RAM. So all proc, the last one that we just did this, and the one that we just checked, which one run, all work on the RAM. So we have directories that work on the hard disk and directories that work on the RAM. Which other famous directories that work on the RAM? Dev directory represents hardware devices on your system. Okay, stored in RAM. Yeah, the temp, we are going to that one. Still haven't made that one. Intermediate memory mounts. These directories use mounting external. Stored in RAM typically are not stored in RAM. Then why did you mention something that's not stored in RAM? Live on disk. Not typically, but in specific cases. So proxies run virtual systems, virtual file system actually. Dev apparently yes. So the other ones are also no. The dev one is interesting. How and why? Let me check the definition we wrote for the dev. This one is also RAM. Why do we need to run diff on RAM? So every time I boot my computer, it will run the hard drive there as if it was the first time it's seeing it. Okay. Accessing device files on RAM is much faster. Okay, because you want to access your hard disk faster, you load the information of it on the RAM, but you have to do it like new every time. Okay. I will not dive even deeper into that rabbit hole now.
So you wouldn't store anything here and nothing gets installed here. TMP is, of course, a temp or temporary directory. This is where files are temporarily stored by applications that could be used during a session. One example is if you're writing a document in a word processor. It will regularly save a temporary copy of what you're writing.
Okay, I see. Temp is for temporary. Temp, which is for temporary, saves the program's temporary files. For example, Word saves automatically that version will be on that folder. How much more do we even have? It seems like actually a lot. Like really a lot.
Here, so that if the application crashes, it can look here to see if there's a recent saved copy that you can recover. This folder is usually emptied when you reboot the system. On occasion, you might find some files or directory that remain and could be stuck there because the system can't delete them. This normally isn't a big deal unless there's hundreds of files or the files are taking a lot of disk space, in which case you might want to log in as the root user in single user mode and navigate to this folder and manually delete them. Moving on, we have
Okay, good to know. Sometimes folder will stuck there after reboot and you will have to manually delete them.
the USR folder. This is the user
Where is the USR folder? Yes, we have this one. Almost there, almost fell.
application space where applications will be installed that are used by the user, as opposed to the bin directories used by the system and system administrator to perform maintenance. It's also known as Unix system resource, and any applications installed here are considered non-essential for basic system operation. Installed applications will reside in one of several places here, such as user bin.
So there is even more inside the USR. Nevertheless, so we also have bin, the same type of files, but this one is for completely different reason. So we have the /USR. I'm not sure which one. I think it was just user. The place where programs that are not necessary for booting exist. The ones that users will use.
User sbin or local bin local sbin with their required library stored in user local lib or user lib. Most programs that are installed from the source code will end up in the local folders. Many larger programs will install themselves into user share. Any installed source code, such as the kernel source and header files, will go into the src directory. This directory seems like a confusing mess at first, and while the directory structure and what goes where is laid out in the FHS I mentioned earlier, you'll still have to sometimes look in other places to find things. Someone may...
Let me type that this one is the messy one. A very messy structure. And because we keep on repeating the other files that we just have seen.
A certain application might not adhere to the standard and could just do what they want. Also, some distros
Yeah.
these folders differently as well. Going back to root, we have next var.
Var.
Var is the variable directory. It contains files and directories that are expected to grow in size. For example, var crash holds information about processes that have crashed. Var log contains log files for both the system and many different applications, which will constantly grow in size as you use the system. You'll also find other things in here like databases for mail and temporary storage for printer queues, also known as the spool. And finally,
Okay.
we will come back.
Actually, so this is the last one inside var. Application that are expected to grow in size. For example, logs of user will be stored there. Let's actually mention also that it means variable. And that's why it's mentioned variable, because it keeps on changing. And this is everything about the root directory. Actually, let me just copy all of this. We will make a separate place specific for that one. Let me just have this one a bit. The root directory. And let's actually select everything here and just make it as 1 to 3 better. Actually, nope. Also nope. Then try doing it again. Yes, now 1 to 3. Now all of these are the folders inside the root directory. We have 17. Oof. And now we are back to the home directory itself.
Back to the home folder. When you enter the home folder, you'll see that each user has its own folder inside of it.
Yeah, I have seen that.
Where you store your personal files and documents. Like I said, each user has their own home folder, and each user can only access their own unless they use admin permissions. Some
Okay.
users mount the home folder on a different drive or different partition, which allows you to reinstall your system and preserve your files. The home folder also contains many different directories which store your application settings. A hidden directory is simply one that starts with a period. Linux hides these by default. You can determine the file manager by selecting Show Hidden Files or by pressing Ctrl H. This is of course using Nautilus in GNOME, and some file managers might be different. PCManFM is also press Ctrl H to view.
But I think if you use the terminal, you will be able to access it. CD home. Where are we? I forgot. Sorry, pwd. That's the slash is right. We know we need to get back to the root and then go to home and then ls. Let's access the user cd and then this guy right here, then ls. It doesn't show the hidden files. Okay.
Hidden files. If you're in the terminal and you list files, it'll only show you what is not hidden unless you specify -A for all. And now you can see.
Okay, I was going to ask again with the command -A. Now we have a new command. ls-a to show hidden files, aka A for all.
All your hidden files. hidden directories store things like cache that some applications, like a browser,
Mm-hmm.
use to store temporary files. Other applications might store thumbnails or information that will be used over and over.
I think I'll save that folder because I know temporary data are a bit more complicated for me, and we are just trying to get through the basics. So now next will be the navigation. Actually, let's check our roadmap. Basic navigation, basic commands, I think we covered that. The moving files and directories. We know about directories, but not about moving files. We will check that part right now. And I think that part is here, creating and managing file directories, copying, moving, renaming, viewing, editing file contents, finding files in Linux. Yes, we probably continue with everything here. It seems to be covering everything related to the basics. We just went a bit extra to see what all the, what's it called? Yeah, one of the things I forgot. What was the ctilt actually means? The user folder home directory. Yeah, the user, not the home, not the root. Okay. We'll be continuing with that one, but I just wanted to see all the things related to the home directory first, so that's why.
Then you have folders like config and local, which store individual application settings. Genie, for example, can be found in config. So here's the Genie folder. Any settings that I change in the Genie options are saved here. If I go back to the home folder, you can see that some applications store their settings straight into the home folder, like GIMP, for example. These hidden folders are also where your desktop settings are saved. Whether you use OpenBox, KDE, GNOME, Unity, they all save their settings here, such
Okay.
as what wallpaper you use, what theme you use, and so on. You can even place your icons and themes in these folders so that you can have a custom look and easily save them for reuse. These hidden folders are important if you want to back up your files and your settings. I covered backups, how to do them, and where to store them in another video, which I'll link in the corner of the screen and in the description below. If you don't customize your system or you don't care to, then you can simply back up all the folders you see here. But if you want to save all your settings, then you might want to include all the hidden files as well. So if you reinstall your system, you simply log in and all your theming will already be done.
Okay, good to know. If you do backup, you don't also save the hidden files. You have to manually do that part. Not manually, just also mention it.
You will have to reinstall your applications, but once you install them, the settings you set for them will already be in place and the applications will run just like they did before.
So good to know that the user information, that's where my racing probably be. Background or any type of customization is saved in the username inside as a hidden file.
So as you can see, Linux is kind of similar to Mac, but very different from Windows. Although it seems like a mess, it's
I don't have a Mac background, so I wouldn't know.
actually a more efficient way of doing things and allows much more sharing of common resources between packages. When it comes to adding and removing software, your distro will have a package manager that will handle all this for you.
That was a lot of information for just the first day. We have 7 commands and a lot of things. The directories, I will not remember them, but if I open them at least once every day, I should probably be able to. Now since we understood basic navigation, let's go through path. Now that we have overview of what the file system, let's how to navigate it efficiently. We will explore the concept of absolute and relative path, which are crucial for moving around the file system. Let's create a practice directory structure. Okay, mkdir /p tilde and project practice subdirectory. Mkdir means make directory. Okay, p option allows us to create parent directories if they don't exist. This command creates a practice directory inside your project directory and subdirectory inside, which none of these actually exist. You are making them, and you are making them through the home directory. My brain is not braining anymore after all that information. I do want to check some other Linux video related to the files.
The Linux file system. It's a cryptic labyrinth of
Boot dev usr bin user is a mess, yes. Sbin home another mess, then libtemp bar etc proc.
directories defined by the file system hierarchy standard. Navigate through it with the change directory command. cd / drops you into the root.
Wait. Did I always know that this was called change directory? Yes. I just forgot.
Then with the ls command, we can list out the contents of this directory. First, we have the bin directory, which contains binaries or executables that are essential to the entire operating system. You can run these binaries from the command line at any time. Things like gzip, curl, and even the ls command that we just ran. But confusingly, there's also an sbin directory. It contains system binaries that should only be executed by the root user, like mount or delete user.
Also, since I am doing that course, and with that course, I'm not sure which one to start now, but since I have this one as 1 day use, or 1 day session, I should say, before it stops, it's better than having it for just 1 hour. So let's start with the distribution. I think I read most of that part. Mark as completed. Next, introduction to shell, terminal emulator, hierarchy CLI, command line interface, born again shell, bash. Okay, there are other shells, I know that part. Prompt description, the default folder where you log in, the $sign, special character. Oh. Okay, these are also all new commands. Getting help is the place where you want to ask if you want to see what a specific command actually do. Okay. What am I? Display current username. Pretty funny. The current username I think here is not sure what happened here. Who am I? HTTPS. Okay, logging in via SSR. Okay, that's where we stop. We don't want to get into SSR right now. We have to write IP, hostname, and all that other stuff. But they do have the navigation here, which the one we are currently doing. Okay, I'm getting a bit too ahead of myself. Let's stop here. Or that part actually. These parts I'll probably read alone because they are just theory, especially the shell part. The prompt is where we will start next time at least. This one is not working for some reason. Forget about that part. And for here, we will be starting again from understanding the path and navigation. Because I already heard about the directories and how complicated it is, I just wanted to make sure I check that part first, understand all the directories. And then we will be doing the basic commands here also later, so it should be good for now. We already learned so much today. And by learned, we didn't learn as much command, but it's just a lot of directory names and what they do. I want to check some other stuff. So basic command, moving, creating files, so that's basic navigations. editing file, yes, they use Vim or Nano. I think we used Nano in school when we were working with the terminal before, but that was a while ago. Shell and other basics. So we have command, path, environment variables, command help, shell, and other basic. What's that? The Linux shell is a command line interface or terminal used to interact directly with the operating system. The shell helps facilitate system commands and act as an intermediate interface between the user and system kernel. The shell can perform complex tasks efficiently and quickly. There are many types of shell available in Linux, including Bourne shell, the C shell, the Bourne again shell, bash. The basic of using a Linux shell include navigation between directory. Okay, so we are using the simple one, but I'm not sure what are the other one. Echo shell basics. By shell, then about package managing service, bash scripting. Is this the part where I should be studying bash? I think. So we have managing files with Vim. That shouldn't actually take long. Yeah, it's very basic. From my experience with Nano, we didn't do that many stuff, but Vim definitely yes. Working with files, file permission, archiving, copying and renaming, soft links, text processing. Okay, that's where these things are. Server review, process management, user management, service management, package management, disk management, booting, networking, backup tools, shell programming, troubleshooting, containerizing. Okay, now forget about these parts. But I want to understand something related to bash. What is bash?
Bash, a command language interpreter for interacting with a computer from the command line. It's also called a shell because it surrounds the operating system kernel to hide its intricate details, while allowing you, the programmer, to do important stuff like access data and write files by typing simple commands. This was a revolutionary concept when it was developed in the early 70s, back when programmers were still using punch cards. The shell concept evolved over the years, with the Bourne shell being the most popular version. That is until 1989, when the Bourne Again shell, or bash, came about. When you open up the terminal on a Unix machine, like Mac OS and most Linux distros, the default shell is usually bash. It provides a prompt where you can type a command, which will then be interpreted by the shell and executed on the operating system. To find out if you're running bash, type in which $shell from the command line. It's like any other application that lives in the binaries directory.
Which, then dollar, shell, and then shell. Okay. Which, and then we have the dollar mark, then shell. Okay, we are also running bash here.
But bash is also a programming language that allows us to write scripts, which means anything we type manually into the shell can be automated with code. When you first launch the shell, it actually runs a startup script that's defined in the bash profile or bashrc file on your system. This allows you to customize the behavior and appearance of the shell whenever you start a new session. You can add your own custom bash scripts to any project by creating a file that ends in .sh or no file extension at all. The first line in that file should always be a shebang, followed by the path to the application that should run it. Below that, we can start writing commands like echo to print something, and they'll be interpreted line by line.
I still don't see how writing custom bash scripts would be helpful in DevOps, so should probably continue where I am first before diving into bash scripting. So that's definitely not the part meant here by shell. Or actually, let's ask, why do we need, or when do we need to use bash scripting? It's an essential tool in Linux and other Unix-like system automating tasks. Okay, so we need it for automation. Now let me check the automation book that we have for Python. If we have a section for or bash, because if this book is about automation, it should also contain that. Manipulating strings, pattern, machine regular expression, reading and writing files, organizing files, debugging, working about that, web scraping, working with Excel spreadsheets, working with Google Sheets, working with PDF and Word document, working with CSV file and JSON data format, program, sending email and text messages, manipulating images, controlling keyboard and mouse with GUI automation. Okay, I think I'll leave bash scripting after I delve a bit deeper into Python, but we'll see. Automating repetitive tasks, simplify complex code, task scheduling, batch processing, system monitoring. But I mean, it's not that difficult from what I have seen. Most of the tutorials about it is very short. I mean, short means like only 1 hour, or around 1 hour to be exact.
If you want to become a hacker,
probably have a tutorial here if he's talking about it. Learn Python, intro to bash. It says here episode 1 now. When did that come? Bash, bash, bash. Bash scripting seems fun because it's a scripting language, so yes, so people are using Python and Bash, not just both. Okay.
Bash scripting is essentially just taking those terminal commands such as like ls,
Mhm.
cd, move, and then compiling it together, linking those commands together to have.
Okay, yeah, having different commands work together to form a new command. So that's basically bashing. Okay.
Essentially, that is bash script. It's just
Okay, sure.
already existing programs, because that's what it is at the end of the day. The program cd, move, ls, concatenate, all these are just programs. Especially like, they're simple functions. They do very simple things, but then start to look at things that are more complicated like grep or awk. These are like proper programs and they have a lot of functionality. Scripting is essentially taking already existing programs and not building it up from scratch, but using the already existing tools
Mm-hmm.
and linking it to have some grand effect. Python, on the other hand, is like a proper programming language, right? You can build programs from the ground up, but also.
So let's the analogy I'll give is programming is the main stone, and then bash is the one connecting the stones together, if that makes sense.
You can script because it's just so like simple to use. Now, if you've watched my videos, you would see that I've made a lot of bash videos talking about how to script this and do this in bash or whatever. However, I've made no Python videos, and to be honest, that was literally just because I didn't learn Python until like very recently. Like only through uni I learned Python.
Mm-hmm.
And now, I was thinking, I'm like, I've always knew like people would use Python for scripting compared to bash, but like when
Why?
is it appropriate to use?
Yes, exactly.
So, yeah, I researched it and I figured out like these are the reasons why and when to use Python or bash over the other. So let's look into the advantages and disadvantages of both Python and bash. Now, the two major advantages of bash is that number one, it's very easy to interact with your operating system, such as like
Because yes, bash is wrapping around the kernel, so you're kind of interacting with the kernel directly if you do that.
easy to like move a file name to whatever you want to, or like change files, move files, like literally like change the file like text information and all that. So interacting with the operating system, it's very easy with bash. As well, bash is quite old now. Bash is, doesn't really update. I don't think there is like a major version of bash. There might be, but the things stay the same. scripts from 30 years ago, scripts that are older than Python itself work fine. So
Wow.
if you want something that's very stable and you want something to interact with your operating system, with your computer, then probably Bash is going to be the choice.
Mm-hmm.
Bash also has some pretty big disadvantages. And one of them, for example, is just making programs with it, making big, monolithic stuff is just a mess. Like after 100 lines of code, it's like it's kind of messy. I'm actually going to show you an example right here. I have this program that I never really used, but it's Hourlog. I actually made this for my ex-girlfriend because she started working, and I don't know, I just wanted to like log her hours and stuff. But why I did it in Bash, I didn't really know anything else, but like this would have been way better in Excel. But essentially, you can just see okay, like it looks fine, declaring variables, declaring okay, Monday, Tuesday, okay, a lot of things I just didn't know how to do, and then using for loops and here's another thing is that Bash is kind of cryptic, like said, like it's like although technically it's no longer Bash, this is just using another program.
Yeah.
But okay, here, this is pure Bash. Dash ZLP. So that's a variable, but dash Z. What does that do? No idea. There's no way you could know. There's no way you could guess, except you have to look at the manual. This just means that if there is no input, if this variable is empty, so it's just really bad. It's just you start looking at it, and just like what the dev to null again. Like you just have to.
Okay, starting to see the differences.
Oh, and this is such a pain. This was such a pain to make. It never. I think it works kind of, but like not very well, not very well. And this would have been like a 10-minute job in Excel. Not even like a 1-minute job in Excel. And you can see this is 137 lines. So I will never do this again. But to add numbers and stuff, it's pain. Like add numbers and then manipulate strings to get like the certain values and stuff. It's just really, really bad. But going back to the advantages of Bash, this right here is where Bash it excels extremely well. Essentially, just few lines. And this is just quicker in Bash than it is in Python, because all you do is that, then you just do, you set like what you want to do, and then piping and like the LS
I heard of the
is
term piping, yes.
D menu. So you can see right here, if I do LLP, this is the first line. It's just piping it's essentially doing LS and then just piping it into D menu, and I can just select, and then whatever it's selected, it puts into the wallpaper variable. It checks if the wallpaper variable is empty. If it is empty, then it just exits there. If it's not empty, then set that wallpaper as my new wallpaper. And essentially, that's how it works. So it's a very simple script, and this is where Bash excels. Now, looking at Python.
So probably if I'm writing something small, I'm doing it correctly in Bash, and if I'm doing something really big, then I'm probably doing it wrong.
Python has many advantages over Bash. For example, more complex processes such as like string manipulation is very easy. So you can see here, I've got some example code, and to know like the exact code isn't important, but if we do something like we got print sum of calories, so if we do that and then we just run it, so we'll see that here we have, it's essentially a list. Now let's say we just wanted the last couple, so we can see that I do here, I just want the last three to, so we could say just give me the last three and that's it. I don't want to explain it, but then okay, boom, just shows you the last three indexed. So it's just very simple string manipulation. If you've ever played with Python, you'll know that Python is it's like a dream to work in. To edit strings, to edit numbers, to anything, just very easy. You can convert stuff back and forth, and again, it's beautiful. Compared to Bash, it's just so much better. Likewise, Python syntax is just very simple to read. Like
yes, it is.
Like, okay, all calories equals list with open, blah 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 as else. Then just read lines for else into all calories, sum of calories equals,
Okay, yeah, I think I kind of understand the idea. Bash will probably be a good way to solidify my already existing knowledge with the terminal. So basic command lines and stuff like that. So maybe, I'm not sure. Maybe after learning more about the command terminal, I'll probably get into Bash just to make sure that I get my command lines correct at least, and make sure that I understand Linux correctly before actually jumping into Python. And I do want to try coding in just Linux in general, so I'll probably do it in Python. So if I want to know how to code in Python, I should probably be really good at understanding Linux first. I mean, for now, we are just doing it in a website, but I do plan on setting it up on my hard drive here, but I forgot how to boot up my computer, so I'll have to figure that issue first. And then after that, we will be start coding and meshing stuff there. Also need to set up OBS on. Okay, configuring OBS will be a pain in the ass to do, so that's another part. But I think that will be it. 2 hours per day for just learning programming is my goal for now, since my brain can barely comprehend what we just went through with all of this. I'll take my time to actually just read them after I finish and get to know them better. And yes, tomorrow I will not be able to stream, or after tomorrow, because I will be coming from work. I will try to maybe stream at night, but I'll be not sure. Depends how tired I will be. But I'll still at least try to read the book about the automation one, this one, because it seems like something I'll be interested in doing, just automating stuff before jumping to the really hard part, which is not even Docker, but AWS. I think that will be it for today for both YouTube and Twitch. I will not be gaming as much because I don't really have that much time nowadays, but it is what it is. I'll see you guys next time.